go over this 12.7 worksheet. So the first part here, it wants us to graph a basic sine cosine function. So just kind of know how basic kind of flows. So this right here starts at the center. That's a sine graph. So it is a sine graph. And all you want to do is kind of follow the point. So it's going to go, when I graph sine, I always say it's the first point, it's the last point, halfway in between, and then halfway between these 2 points is your max, your amplitude. Halfway between two is your min. So we're just going to try to follow that line. Let's look something like that. That's not my best graph ever, but that's kind of the idea. So that's what a sine graph looks like. Again, I always start with, okay, first point, last point, midpoint. Halfway between these 2 points is my max. Halfway between these 2 points is my min. Then you go to, this is a cosine graph. It starts at the amplitude. So for cosine, I always think, okay, first point, last point, like always, they always match. Halfway between is your minimum, and then halfway between these two crosses your x-axis. Or crosses your, we'll eventually do more advanced graph, we'll cross our principal axis. But it crosses the middle, basically. So first point, last point, halfway between is the lowest, and then halfway between those two crosses the middle. So then we just try to graph it. So it looks something like that. So this is a basic sine graph, this is a basic cosine graph. The graph is not perfect. Okay, here let's talk about how to find the amplitude and period. Remember, amplitude is the number in front of the sine cosine function, so it's like this. This is my amplitude. It's the absolute value of that, actually. It's the absolute value of A. So I don't care if it's plus or minus, it's always positive. And then my period has to do with the B value here. The period is always 2 pi over B. So if I was going for this one here, my amplitude, there's no number for the sine, so it's 1. And the period is 2 pi over 4, that's my B. So 2 pi over 4, which I can reduce to pi over 2. The next one here, again, no number, so 1. And then my period is 2 pi over my B, which in this case is 5. So I get that. Ampere is 1. My B is 1. So we'd be 2 pi over 1, which is just 2 pi. And now here we have a negative 4, but the amplitude is always positive. Negative lets you know how the graph's going to go, so it's a vertical flip. But the amp is still like, how far from the origin do you go? Or from the midline do you go? In this case, it'll be 4. Right, so amp, so I guess I should probably do this. There we go, and then we get 4. And then the period's 2 pi over 5. The next one, again, I'm trying to trick you. So my amp is going to be just 2. And the period's 2 pi over, it's a bit ugly too, over 1, which is just 2 pi. Over here, my amp is 3. My period, I'm just being a jerk here. So it's 2 pi over 2 over 3. Or we can't leave it like that. So the way I generally do it is I rewrite it. This is like saying 2 pi divided by 2/3, which is the same thing as saying 2 pi times the reciprocal, the right hand side. These cancel out, I get 3 pi. Alright, so a fraction over a fraction, just divide it. So you flip the right hand side. So now we're going to graph given all this information. So first is the amplitude. I always like to write stuff down, this makes it easier for me to graph. So my amplitude is here, it's 3. My period is 2 pi over B, which in this case is 1, so just 2 pi. So my amp is 3, my period is 2 pi. I'm graphing a sine function, so remember sine starts at the origin. So I'm going to start here. I'm going to end at my period, which in this case is 2 pi, so over here. Halfway in between. And halfway in between these two is my highest. So again, my amp is 3, so the highest I could go is here. The lowest I could go is here. So half between these two is my highest, which would be right there. And half between these two will be my lowest, which would be right here. Let me just try to connect those dots. So into that effect. Again, this graph goes on for over and over again. Just keeps on. If I was going to draw it correctly, just keep on going. This is only one period I'm showing here. This next one, 4 cosine 2x. So my amplitude is 4. My period is 2 pi over 2, which is my B. So I just get pi. So again, let's start with the first. It's cosine, so let's start with our amp. 1, 2, 3, 4. So right here, I start at 0, and I'm gonna end at pi. So right here. Now remember, cosines. You always start and end at the same spot. Halfway between cosines is the lowest, which would be -4. And then halfway between these two, which is like around here, would be where I cross the midline, the principal axis. And it's sitting on this side. So this is a cosine function with a period of 2. So you can see the period of pi. So you can see it's like shorter. It repeats every pi instead of every 2 pi. So it's like this. Now, if you look at the instructions, then sketch the graph of the function over the interval. So they want me to sketch it for the whole graph. So I'm just have to repeat my process. So I started here. I end 1 pi over, which will make me 2 pi. Half between my lowest. Half between those two is where I cross. And where I cross. And you just draw another rotation. So it's like that. So these are going backwards. So I give you a graph, and now I want to find some stuff about it. So I gotta find the amplitude, the period, what the equation is. Now period's the hardest one here, and we'll talk about it. Amplitude is the joke. Look at this one. What's the amplitude? 3. That's how high and low it goes. Remember, it's always positive. Period is a little tougher. So period, remember the way we find it's a formula. The period equals 2 pi over b. So the key here is find the period and plug into the formula because we got to find b for our equation. I guess finding the period itself is not hard. Finding b is hard. Sorry about that. The equation, let's write the basic one so we know what we're talking about. So the equation here, it starts at the origin. So this is a sine graph. So my basic equation would be y equals a sine b, bx. So we got to find a, which is the amplitude, and then we got to find b, which is the hard part of this. So first let's talk about the period is. So much like the last lesson, right? You pick a spot, and then see how long it takes to repeat to get to that spot. That's how long does it take to do one full cycle? So I start here, I go up, I go down, I go up again. So right there. So my period would be pi. That's how long it takes to repeat. Now, so period, like I said earlier, I was a little wrong. Period is not that hard, hopefully. It's finding the b that's a little tougher. Because that's not your b, right? Period equals 2 pi over b. So to write the equation, I need to figure out what my b is. So I'll plug it in. Pi equals 2 pi over b. Now you probably figure out that b equals 2. Or you just cross multiply real quick. And you get 2 pi equals pi b. Divide by pi. And b equals 2. So if I write the equations, be y equals 3 sine of 2x. Like that. Next one. This is a cosine graph. I can tell because it starts at the amplitude, right? So you go to origin, you start at the amplitude. So that's a cosine graph. So my basic equation looks like this. My amp is 4. Super simple. My period, how long does this take to repeat itself? So start somewhere. How long does it take to go? One full rotation right there. That looks like 2 pi. Now remember, a is the amplitude, but my period is not b. There's a formula for this. Period equals 2 pi over b. So in this case, my period is 2 pi, so I got 2 pi equals 2 pi over b. And that makes b equal 1. Again, if you want to cross multiply to solve it, but if I plug 1 in for b, it works. So there's my equation. Y equals 4 cosine 1x, or just x. So that's how you go backwards. You always want to find the amplitude, which should be the easy one. And then finding b is a little tougher. You got to figure out what the period is. And then once you found the period, you got to go back and plug it in. So for the next problem, I want to use a calculator to sketch the following tan graphs. I think I talked about how to graph them basically, but most of the time in this class, when you find a tan graph, we're going to do it with a calculator. Next year, we'll start doing it a little bit more by hand. So with this one here, grab my calculator. There's a couple things you got to make sure of. So when we graph trig functions, 98% of the time you do them, you want to do it in radian mode. Probably more like 99% of the time. So make sure you're in radian mode. Right, so if we're in degrees from like the last couple lessons, you just want to go back and hit radian, hit enter, so you get out there. And then we're just going to type it in. So we go to y equals. I'll type in tan of 2x. So remember, we don't have data, but I'm just using x. Now, before I do anything, I want to fix the window. Notice it says from 0 to 2 pi. So I'm going to go to window. Because if I just graph it now before I fix it, you're going to see a bunch of tan graphs going on forever. I want to encompass within the window we have. So I'm going to go 0 to 2 pi, like I said, for my x. So then 2 seconds pi. And then scale we keep at 1. A ymin, ymax. Look at the graph here. It goes from -4 to 4. So I'm going to type that in. Hit graph. and you get something like this. There we go. Now again, it's just a sketch to make sure we know what we're talking about. So something like that, and then it looks like we're gonna go here. Oh, that is a bad graph. Something to that effect. The period width. So I forgot to do the period. Remember the way you do period? It's a little different than sine and cosine. Period is pi over b. That's the form for the period of a tan graph. So here will be pi over 2. So that's my period. The next one here, my period, pi over b. Well, my b here is 1. So pi over 1 or just pi. Again, I'll just type that in my calculator and graph it. So y equals tan parentheses, theta, so x, plus 5 pi over 4. So 5 pi divided by 4. And we get a graph that looks something like this. You see the period's a lot more stretched out than last time. So it looks kind of like this. And this is a lot more stretched out. And same thing here. Man, this middle one looks terrible though. Some side effects. Again, since it's a sketch right now, we'll go over this more next year. Given the amplitude and period of each function, then sketch the graph of the function over the interval from negative 2 pi to 2 pi using the key points of each function. So let's talk about y equals 2 cosine x. Alright, so just like before, the amp is 2. The period is 2 pi over b. In this case, my b is 1, so just 2 pi over 1, or just 2 pi. So let's start the origin like we normally do. So it's a cosine graph, so I'm going to start with the amp, which in this case was 2. We're going all the way to 2 pi, which is a little hard to see here, but that's like right there. That's where 2 pi is. Then halfway between that and that would be pi, and go down to negative 2. A little bit past 3. Half between those two is where you cross, which would be pi over 2. And our cross would be 3 pi over 2. And that would be our graph. That. Now they want us to fill the whole graph up. That's a pretty bad graph. So I'm going to go backwards the same way. So if I start at 0, I'm going to go all the way to negative 2 pi. So right here. So right around here. Half between those two would be negative pi would be my lowest. Half between those two is right across. And graph goes the same thing this way. And then from here we're just going to try to continue it on. So it goes down, goes up, goes down. Okay. So that's the graph for the whole way. Next one here, negative 2 sine x. So my amplitude is negative 2, but actually it's just 2. Because it's how high and low you go. My period is 2 pi over b. My b is 1, so just 2 pi. So sometimes I like to write like this. So the amp is 2, so highest I can go is 2. So it's like the, like the little dollar line. That's the max I could go, right? And lowest I go to negative 2. So now I know my lower range. Besides the fact that this right here is terrible. There we go. We're starting at 0. I'm going to go all the way to 2 pi. So 0 to 2 pi is we're end right here. Right, so that's a little graph for this guy. Then we're going to do a sine graph. So we start at the origin, end, same spot, halfway between. Now it's a little different than negative because it's flipped. So instead of the point between these 2 points being up here, it's going to be down here. Right, it's flipped, so we're going to go down then up. So like right here, halfway between, and then right here, halfway between. So that's my trouble sine graph. That looks awful. It's kind of like this. That's a little better. So that's our sine graph, and again, it continues on. Like that. So it should curl up, I think. We're just going to do the exact thing backwards. So start at 0, we can go all the way back to negative 2 pi. Halfway between to my middle. Since we're going backwards, half between here, just like follow the flow of it, right? It'll be the highest point, halfway between. Halfway between these two is my lowest point. So it's kind of like this. And I'm not having a good day drawing these. Something like that. Let's move on. That looks disgusting. Okay, more going backwards, right? Remember how we did these earlier? So, find the amp is easy. Amp is just 2. For the period, it's how long does it take to repeat itself. So if we start at the origin, how long does it take to do one full rotation? That'd be 4 pi. So my period's 4 pi. But I want the equation. Now this is a sine graph, starts at the origin. So it's a sine graph. So the basic equation looks like this. So my amp would be 2. The b is tougher to find, right? So to find b, you gotta do period equals 2 pi over b. And my period is 4 pi. So 4 pi equals 2 pi over b. We'll do a little cross multiplication. 4 pi b equals 2 pi. Divided by 4 pi. B equals 1/2. So 1/2 x. Right, so again, find b is the tough part. You figure out what the period is, and then set that equal to 2 pi over b. And then you just do the math. So cross multiply, solve. The one over here. What's the amplitude? Well, it looks like 5 and 5, so 5. Period, how long does it take to repeat itself? Start down here, go up, go down. 2 pi. That's make my b really easy. My equation, this is a cosine graph, starts over in the amplitudes. Now if you notice, it's upside down, so it's actually a negative cosine graph. So it's flipped. And now all we gotta do is find our b, because we know what our a is, right? So to find b, it's period equals 2 pi over b. My period's 2 pi. That'll make my b 1. So I'm going to have the equation y equals negative 5 cosine of x. Next one, some more graphing. Just some practice. So y equals 3 cosine 1/2 x. Again, I always like to write down what they are. So f is 3. Period equals 2 pi over b. My b here is 1/2, so it's 2 pi over 1/2. Remember the way you do that is divide. It's a divide sign. So 2 pi divided by 1/2. Rewrite that. It's 2 pi times reciprocal. So 4 pi. So I'm going all the way to 4 pi. Oh, now this is tough. So let's start with cosine, right? We start at 0. My amp is 3. As high as it go. My lowest goes to negative 3. My period's 4 pi, so it's actually double this. So like if I was doing a full graph, it would actually go all the way out here. So let's just do a cosine graph, right? Start at 3. You would end the same spot, which is like over here. I don't have that spot. Halfway would be 2 pi, and that would be my lowest. And the half between these two is where I cross. So the only part I actually have is this part. I can do the same thing back here, right? I go all the way out, don't have that. Halfway would be 2 pi, and that would be the lowest. And the halfway would be right across, so it's not like that. So it does look like a cosine graph at the end, but it's because you have two halves. You have the half of this side, and you have the half of that side. So that was a tough one. The next one, a little simpler cosine graph. My amp is 1. My period is 2 pi over 3. And that's pretty much it. So on this one, we start at 0. We're going to end at 2 pi over 3, which is like right here. It's going to be a very short graph. Look at that. Alright, starts at 0, you end at 2 pi over 3. My amp is 1. So if I goes 1, also goes negative 1. So the little box is going to be my graph. It's a cosine graph. Starts, change the color so you can see it. Starts at the corner, starts the amp, and at the amp, same spot. Half will be between my lowest, half will be right here. Half between that is where you cross, that's cross. So it looks kind of like this. That little graph right there is the graph of cosine 3x. Right, because this thing shrunk the period down by like a factor of 3, so it's really small. And then I gotta repeat this process, so keep on going. So like this, and like this. Same back here. Same side effect, right? Because I want to fill out the whole grid. If they asked it to. In this case, I think they did. No, they didn't. I mean, I probably could. So in this case, they didn't say so. So if I wanted to, I could probably done away with one period of it. Should be probably okay. I would like to draw the little dot so I know that it goes on forever. So it's going backwards in a different way. Find the equation of a sine function that has amplitude of 4 and a period of pi. Right, so it's a sine function, so it looks like this. Sine of dx. I know the amplitude is 4, that's my A. Period has to do with b, but it's not b. So right, period equals 2 pi over b. And I know the period is pi. So pi equals 2 pi over b. Put over 1, cross multiply. I get pi b equals 2 pi. Divide by pi. I get b equals 2. So then, there we go, everything we need. My equation will be y equals 4 sine 2x. Next one. Same idea, but find the equation of a cosine function. So y equals a cosine dx. For the amplitude is 3/5, that's my A, and my period is 3 pi over 2. So it's the same type of question, just, right, this is always the tough part. Period equals 3 pi over 2. Sorry. Period equals 2 pi over b. And that's 3 pi over 2 equals 2 pi over b. So all we gotta do is cross multiply and solve. So cross multiply, I get 3 pi b equals 4 pi divided by 3 pi. Cancels out, b equals 4/3. So now we have everything we need. Y equals 3/5 cosine of 4/3. And there you go, that's the answer for that one. I think the rest of this worksheet is practice of unit circles, which again, that's how important this stuff is. So I'm just going to do this real quickly. Sine of 45. Again, I like to do the triangle method. So this is 45. So it's a 1, 1, 2. And then sine is slope to opposite hypotenuse. 1 over rad 2. Or if you want rad 2 over 2. Again, the key to doing the triangle method, if you want to do it that way, you can also do the table method or have to memorize, is you have to know the triangles, right? So this is a little review. 45 is an isosceles triangle, so it's 1, 1, rad 2. Rad 2 goes in the hypotenuse no matter what. Doing it this way. 30 degrees, that's the smallest, so it's the opposite to 1. Hypotenuse is 2, and then rad 3. And then with a 6-degree angle. 6 is the biggest, so it gets the rad 3. Hypotenuse is 2. And adjacent is 1. So again, I treat like 3 separate triangles. And if you have that down, the rest of it's kind of easy. Cosine 30. 30 small, so it gets to 1. Hypotenuse is 2, so it's rad 3. Cosine is ka, so ga toa, so adjacent of hypotenuse. Tan is 60. Here's 60. Opposite 60 is rad 3, 60 is big. Hypotenuse is 2, adjacent is 1. Tan is toa, so opposite for adjacent. That's not adjacent. Opposite for adjacent. Rad 3 over 1. Rad 3. We have radian here. We actually have the reciprocal functions too. So remember the way you do reciprocal functions? Just do the normal function. So sine's opposite of cosine. And then just flip your answer. So cosine 2 pi over 4. So remember the way we do radians is the trick. You make this pi, you make it 4 over 4. So if we're going 3 pi over 4, because we know it's 0 on pi, so you just make this whatever the denominator you're talking about. So 4 over 4. 3 pi over, we haven't got there yet, so it's in this quadrant, quadrant 2. Over 4 is automatically 45, so it should be 1, 1, rad 2. If you're pro, you remember how to do the negatives. When you go to the left, it's negative. When you go up, it's positive. Cosine is ka, adjacent hypotenuse, so negative 1 over rad 2. Then we gotta flip it to do secant, so negative rad 2. And that'll be the answer. Again, another way to do the signs, if you want, is all students take calculus. And only sine is positive in quadrant 2. So we're doing cosine essentially, so it's negative. Cotan of 5 pi over 3. It's opposite of tan. So here's 0, here's pi, so I'll make that 3 over 3. You gotta get all the way to 5 pi. Right, so this is 3 over 3, so it'll be 2 and that'll be 4. I get a 5, so I gotta go around again. It'll be 6 pi over 3, so now it's 2 pi. And we haven't got there yet, we're a little short, so it'll be right here, quadrant 4. Over 3 is automatically 60. Opposites are at 3. Adjacent 1, hypotenuse is 2. And then the negatives here, how they work? Well, you went to the right, so that's positive, but you went down, so this is negative. Hypotenuse is always a positive value. So cotan is opposite of tan. TOA, opposite over adjacent. Negative rad 3 over 1. But since we're doing cotan, we have to flip it. Negative 1 over rad 3. Or rad 3 over 3 if you don't rationalize. Cosecant of 7 pi over 6. So here's 0, here's pi. 6 over 6. I'm going to go a little past that. 7 pi over 6. Right, and then over 6 I'll make it 30. So I show my initial minus side. It's 1, 2, rad 3. We went to the left, so this is negative. We went down, so this is negative. Hypotenuse is always positive. Cosecant is opposite of sine. So we're going to get so. Opposite of hypotenuse, negative 1/2. But again, we're doing cosecant, so you have to flip it, negative 2. Cosine 270. 0, 90, 180, 270, 360. So 270 is right here, it's on the line. Remember, you're on the line, it's on the special ones, the unit circle ones. The coterminal angle. So you should know the point there, and that point is 0, negative 1. And then cosine, sine e, sine the y, cosine the x value. X value there, 0. That's all it is. Anytime you find on follow along the lines, following the coterminal angles, it's just the unit circle point, and then you got to figure out, okay, the x or the y. Cosine x, sine of y, tan is sine of cosine, so y over x. Like the next one. Tan of 90. So tan of 90, let's use this graph right here. It's right here. So 0, 1. So tan is sine over cosine. So sine e. So y over x. So my y would be 1 over 0, which is undefined. Tan divided by 0. Sine of 180. We'll just use a graph again. Here's 180. Negative 1, 0. Sine e. Sine's the y value, so 0. If you know those, they're like the fastest ones. Now use some of these. Okay, so when I do radians, you could find a coterminal angle, but with radians, I think it's just easier to go around until you get the right answer. It's people don't like to subtract fractions from fractions. So we have 0, we have pi, and right here we have 4. We have over 4, so this is 4 over 4. Right, I gotta get all the way to 11, so 4 over 4, 8 over 4. If I go around again, just by adding the denominator, right? Add another 4 over 4, and you get 12 over 4. Well, I need 11, so I'm a little short of them, a little bit, like we're going around this way. So I haven't got there yet, so I'm right here, quadrant 2. If you do it, over 4 is automatically 45, so 1, 1, to negative, you went to the left. Tan is TOA, opposite of adjacent, 1 over negative 1, just negative 1. So the next one, cosine of 17 pi over 3. So here's 0, here's pi. Here's 3 over 3. Now I'm not going to write all these down because I'm going to be here forever. Right, but it's 3, 6, 9, 12, 15. Still not close enough. 18, so a little short of that, so 17 right here. Right, so again, just going over again. Here's 0, then you go 3 over 3, and then you go around center of 3 over 3, so 6. So then 9, then 12, 15, still not close enough. You want to be 1 away. Then you go around and you get 18, but we haven't got there yet, so a little short, so 17 pi over 3. And that makes it 2 over 3, so that makes it 60. Opposite 60 is rad 3. 1, 2. What's negative? You went down, so this is negative. You went to the right, so it's positive. Hypotenuse is positive. And then cosine, so that. So 1 over 2, 1/2. Sine of 19 pi over 6. I'll do the same way. I won't bother you with all the details. So this is 6 over 6. Right, so we go 0, 6, 12, 18. I'm going to go a little past that, so 19. That's 30. So 1, actually 2. Negative and negative, so you went to the left and you went down. And reduce sign, so we get to opposite of our hypotenuse. Negative 1/2. Now we're going to graph secant and cosecant. And finish up our lecture here. Now, graphing secant and cosecant is actually super easy. All you gotta do is give sine and cosine a little makeover, basically. So I'm gonna do that first. We're gonna graph the reciprocal function y equals 3 sine cosecant opposite of the reciprocal sine, so 3 sine x. That's what we're gonna graph here. Right? All the rest of this is the same. Amplitude is 3. My period is still 2 pi over b. My b here is 1, so 2 pi. So what we're going to do is I'm going to graph sine, I'm going to do it kind of dotted. So my amp is 3, so go to 3, go down to 3. My period is 2 pi, so sine starts at 0, and at 2 pi. Halfway between right across. In between the first two is my max, which is at 3. In between the last two is my min, negative 3. So we're just going to graph it. Now I'm going to do it dotted, so because it's not our answer. So this is not going to be our answer, but it helps us get our answer. That's why I'm doing it dotted. So there we go. Now going to make this a cosecant graph. What we're going to do is do this. Get that 2 things. Add asymptotes, where it crosses the midline. Principal axis, whatever you want to call it. It's like right here, where it crosses the middle, basically. So we have those asymptotes, we're looking for asymptotes. And then our actual graph is to make parabolas at the min and max points. That's it. So right here, draw a little parabola. Don't go past the asymptotes. They're perplexes and cross them. There we go. So these purple graphs are the graphs we want. So that's a graph of sine and cosine. That's a graph of cosecant. We'll do overstanding over here with secant. Alright, so my f is 2, my period is 2 pi over b, which my b here is 2, which is pi. So secant is opposite of cosine. So remember, cosine starts at the end, which in this case is 2. And then we end at a period, which is, so like, let me do the dotted thing. We start at 0, we end at pi, right, with my m. 2, over here, and then negative 2 to the lowest negative. So this little box right here is my cosine graph I got drawn. So 2 cosine 2 theta. So half is 2. So I start here at the end here also. Halfway between my lowest. Halfway between those two is right across, right across. So I should be dotted. It's not the final answer. Something like that. Why is my dotted line so much nicer than my non-dotted lines? So something like that. That's such a nicer graph than my solid lines. So that's a graph of cosine, right? But I want secant, so we do the same thing. Give a little makeover. Yeah, asymptotes at where it would cross the x-intercept, x-axis, or the middle. Can't see the term for it, but it could be different. Like either principal axis or midline, whatever you want to use. Like that. And then, which is a little easier to see, at the maximum endpoints you want to add parabolas. So like right here would be like half a parabola, like this, or don't go past the asymptotes. Right here would be like that. It would be like this. Something to that effect. And again, the graphs in this case, the red colors, are the actual graphs of secant. Okay, last two, and then you're done. So same thing here, let's find the amplitude. Amplitude, there's a negative 1 outside, but there's always 1. That just lets me know it's going to flip. My period is 2 pi over b, which is 2 pi over 2, so it's just pi. So I'm going to start at 0. My amp is 1. Oh, that's in the small graph. And negative 1. and my period's pi, so net pi. And probably negative 2 pi. So this graph, this little box right here is like where my cosecant graph is. It's in this box. In here. Actually, where my with opposite cosecant sine graph is. So let's draw a sine graph. Remember, sine starts at the origin, so it starts right here, ends at the origin, halfway in between. I was going to take a picture of that this one also. Now, normally halfway between is the highest. Halfway between the first two is the highest, but this is a negative sine graph, so we're flipping it. So it's actually going to go down then up. So halfway between my lowest, halfway between my highest. Draw a little dotted line, connect it all the way for the rest of the graph. So like that. And again, I want to draw cosecant, so I have two things. Well, I have some asymptotes. I remember my x-intercepts. One more. Right, remember you can't cross those lines, and then to graph the actual cosecant function, just add the parabolas at the maximum point, and that is the actual answer. The parabolas. So there we go. One last one. Secant is the opposite of cosine of 4 theta. Just find everything. Amp is 2, period is 2 pi over 4, which is pi over 2. So it's going to repeat itself at pi over 2. So let's do that first. Right, start at 0, you're going to have pi over 2. My period is 2. So like that. Now again, if I want to draw this up to interval, I got to keep on going. So this is my first so that's my first cosine graph. It's going to be at. How long will it take this second? Well, here's pi over 2. Add another pi over 2, you get pi. Add another pi over 2, you get pi over 3 pi over 2. Add another pi over 2, you get 2 pi. So I have 4 rotations, 4 periods here on this graph. And then it's a cosine graph, so it starts at the amp, ends at the amp. Halfway is the lowest, halfway through you cross. I should have made it dotted, but past that now. Right? And then halfway through cross-ish. So keep on going. I'm not going to be less one with the last ones. Since that effect. Right? But that's not the actual graph we want. We want to make it a secant graph. So at the x-intercept, we draw asymptotes, which should definitely be dotted. It's getting lazy here at the end. Very sloppy to their answer. Very sloppy at the end. So this is sloppy. A lot of dark colors. Okay, so into that effect. And then we add the parabolas, which is the actual part of the graph. So I'm doing like some pink so you kind of see it. At the max, make one of the little parabolas. There we go. That's our actual answer. Sunset effect. The pink. Right, again, if I actually clear all the rest of the clutter, you can see what the actual answer is. All the other stuff just helps us get there. There we go. Sunset. Right, so that's what the actual graph of secant looks like. All the rest is just helps you get to that point. Anyway, that's the lesson.